Good day, ladies and gentlemen. This is Sarah van Grennen, aka Mr. VG, and I love this section of work, probabilities. So I took question 12 that comes from the Department of Basic Education 2021 November exams and broke question 12 up into two sections. The reason why I did this is specifically because it covers two completely different sets of work. Question 12.1, which is actually grade 11 work. And then you've got question 12.2, which is your grade 12 work about counting principles. So what I want you to try and do for me, if you haven't done it already, is answer this question about 12.1. I'm going to give you, take 5 minutes or take 10 minutes and do it yourself. And then you hit the play button again and you look at the rest of this video. So when we look at question 12.1, the first thing that I've got to go and do is again analyze the question. So first of all, they say the question is that are A and B mutually exclusive? I decided to jump into this question simply because it is 1 mark. 1 mark. Now, mutually exclusive means the probability of A and 0 or A and B happening is 0. Now, how does this look if I talk about a Venn diagram? If you are unsure about Venn diagrams, I encourage you to go and look at videos about Venn diagrams. Go back to your grade 10 and 11. Soon we'll have videos as well up on Venn diagrams. That's my promise to you that you can go and have a look at with us. So when I look at this Venn diagram of probability of A and B being 0, it means that A and B does not overlap. But when I look at the question, the information, it says that the probability of A and B is 0.3. So are A and B mutually exclusive? No. What does mutually exclusive mean? It means that A and B cannot happen at the same time. Get that, ladies and gentlemen? At the same time. This is very important for the rest of this sum. Okay, the rest of question 12.1, we are going to need this bit of information. Let's look now at the question 12.1.2. But for me to do this, I must first backtrack a little bit. Let us go and analyze the information. Let's go and mine this, break it apart, make sure we get this right. If they tell me that A and B are independent events, that's the first thing you've got to know. It means that the outcome of A and the outcome of B does not affect one another. So the probability of A and B is equal to the probability of A times by the probability of B. That is very, very, very important, okay? Ladies and gents, I cannot stress this for you. They are going to ask you about independent events in your exam, and this is the formula you are always going to need. It is further given that probability of A and B happening is 0.3 and probability of only B happening is 0.2. To picture this without the Venn diagrams, you are going to struggle. Okay, I'm not saying it's impossible, but you are going to struggle. So what I would encourage you to do is actually draw a Venn diagram. If I look at the Venn diagrams with A and B being your two events, first of all, the probability of A and B happening is where the two circles overlap, which is that middle part. Where is the probability of only B? That means it can't touch A. It does not touch A. It's got to be just inside of B. That means it's that part there. When I now put those values on my sketch, that middle part is 0.3. And therefore, the probability of only B, the red part, is 0.2. What can I deduce from this? This is important. This means something. It means I have the probability that B happens. That is 0.3 plus 0.2. So the probability that B happens is 0.5. When I look at the rest of the sums, there's not more information, or the rest of the information. I can't mine anymore. So what I need to do is just copy this over and now look at the question that is asked. Determine the probability of only A happen. But please remember, this is a 4-mark question. To get that little green question mark area there. So how can I go towards it? It's 4 marks, so I'm not necessarily going to be able to go directly at this question. I've got to kind of go, around the mountain. I've got to kind of do something else first to get there. What do I need to do first? Is I actually need to calculate the probability that A happens. Because if I've got the probability that A happens, I can get the probability that only A happens. But what information haven't I used yet? Well, A and B are independent. So the probability of A and B is the probability of A times by the probability of B. I haven't used this information yet, so I'm going to use it. Again, why is this? Because it is, the two events are independent. So if I substitute the values in, the probability of A and B happening is 0.3. Remember that was given to you. The probability that B happens is 0.5. If I divide both sides by 0.5, I get a probability of A as being 0.6. What does it mean for the sketch? It means the whole A is 0.6. So how much is that green part worth then? Well, the probability of only A is taking the probability that A happens minus the probability that B happens, of A and B happening, sorry. A silly slip of the tongue there by me, okay? So when I look at this question, and I could just as well go say, oh, but so isn't that just 0.6 minus the 0.3 that lies in both? It's exactly. I just write it down in fancy mathematics. So in other words, the probability that only A happens is 0.3. And ladies and gents, I don't just go and write this down. I don't just write it on the paper. I always transfer it into the sketch. Because transferring it into the sketch, I can now go and maybe read off something else from the sketch. Well, this is a sample space. And the sample space means that the probability of something happening in this is always going to be equal to 1. Which means adding all the probabilities in my sample space, the answer has to be 1. So this means outside of both of those, there's 0.2. Huh? Okay, wait, where do you get the 0.2 from? Well, if I take the 0.3, the 0.3, the 0.2 plus something, the answer has to be 1. And that something is 0.2. That's basically what this means. So let's look at what does that 0.2 mean. It means that if A, for instance, now I'm making this up for you to understand. Let's say A was playing hockey and B was basketball, or doing archery and basketball, A and B, archery and basketball. The 0.2 is the probability that someone doesn't play either of those. So neither archery nor basketball. But we need it because if I look at the rest of the sum, I'm going to need that 0.2. So always write in these things the moment that you have completed a sub-question. For me to understand this question B, ladies and gents, I have to draw it on a sketch. Let's take a question as if I've got no information. So the probability of A not happening, so probability of not A, means outside of the circle. So I went and I colored in all the blue parts there. The probability of B not happening means outside of B. So I'm going to take an orange color and color in outside of B. I hope you get that. So I took blue and I colored outside of A. And I took B and I colored outside of B using the orange. Now when I see the word or, I must remember it means every colored in part. So every part of this sketch that is colored in by some kind of part will form part of this probability. Looking at the original sketch, it basically means the probability of A or not B happening is everything that's colored in with a dark red now. So all of those dark red stripy parts is colored in, which means it's 0,3, 0,2 plus 0,2. And my answer is 0,7. There is an alternative, ladies and gentlemen, which is the only part that's not colored in is that 0,3. Let me do it in blue. 0,3. So I could just as well have gone and said it's everything but the 0,3. So everything but the 0,3, which also gives me 0,7. When you get these kind of sums, it's so worth it to draw a Venn diagram. I actually don't know how you would answer this question without using a Venn diagram, ladies and gents. That's my honest to goodness opinion. I don't know. So I encourage you, when you get these kind of sums with A and not A, B or not B, to be or not to be, I'm going all Shakespeare here. I think I must end this video now. But whenever you get these kind of sums, ladies and gents, draw a Venn diagram if it will help you. So this is Mr. VG signing out. Have a gorgeous, amazing and beautiful rest of your day. Please make sure you have this covered and tune in for our next video, which is going to cover counting principles in probabilities. So have an amazing day, an amazing year, and give it all you've got. Cheers.